So now we're going to look at solving simultaneous equations involving the graphical method, where we'll graph the two equations on a graph, on Cartesian plane, and we will get the solution to the simultaneous equation by the point of intersection, right? Where the two lines cross each other, we call that the point of intersection, and that would give us our values for x and y, which would be the solution to the simultaneous equation. Now, to do this, we actually need to graph the two lines, or we need to create a table of values for the two lines. Now, the two lines we have, which will be the two equations, will be y is equal to x plus 1 and y is equal to 2x minus 1. Now, each one of these, we're going to create a table of values. So I'm going to have my y is equal to x plus 1 and my y is equal to 2x minus 1. Now, to draw a line, we just really need like 2 to 3 points, right? So I am going to do over the table of values, and I am just going to use -2, 0, and 2. Right? 3 points. Now, I'm gonna show you all how I would write up my table of values. It might be slightly different to what you would be accustomed to seeing. Now, based on the equation of your line, you could choose appropriate values that would make sense. What I mean by that is that you don't want to choose values that then end up with a very large value that can't fit on the graph page, right? So I tend to choose small values depending on the equation or the line so that I can get things like under 10, right? Not too large, so you can fit it on the graph page. Now look at how I'm going to split up the we don't really need to split up this one. This one we just want to take whatever x is and add 1 to it. So here x is -2. So look at this. -2 plus 1 is going to give me -1. That's my answer here, -1. I'm working out what x minus 1 is. 0 plus 1 will give me 1. 2 plus 1 will give me 3. These are my y values. Y is -1. That's what you get when you add -2 and 1, 0 and 1, 2 and 1. Here, I'm going to split this up into 2 parts. I'm going to work out what 2x is first, then I'll subtract 1 from it. So 2 by -2 will give me -4. 2 by 0 will give me 0. And 2 by 2 will give me 4. I will then subtract the 1 from it. Right? The answer that I will get will be my y value. Y is equal to 2x minus 1. We're working out 2x minus 1 here. -4 minus 1 is -5. 0 minus 1 is -1. 4 minus 1 is plus 3, sorry. Now, you all may be accustomed going and take each one of these values and substituting it in here to work out the same thing. I'll show you how to do it in a table. All you're doing is you're taking the equation, right, 2x minus 1, and you're writing it vertically. So you're finding out the values of 2x, and then you're subtracting 1 from it. Every time you change a column, you're changing the value of x. So here, 2 by -2 give them a -4. Here, 2 by 0 give them a 0. Here, 2 by 2 give them a 4. And then I continue by subtracting 1 from it, and I'll get what y is, because y is 2x minus 1. Now, after I do that, these values here are going to provide coordinates for points. So I'm going to write the coordinates. So this is -2 minus 1. This is my x and my y values. You see x here and y here? Right. The other one is 0, 1, and the other one is 2, 3. You only need 3 points, or really 2 points in order to draw a line. We just do 3, just to be safe. X, y. First coordinate is -2 minus 5. So we get -2 minus 5. Then 0 minus 1. It's this and this, and then 2 and 3. Everybody understand how the table of values relates to the points that you need to draw the line? Anybody do understand? Just give me a thumbs down. Everybody good, right? Right. Now this applies to not just simultaneous equations, but just generally drawing doing a graph. Right? So maybe you should get some bigger lines. I'll look better. So remember on our X, so I'm gonna do two separate graphs, right? So when you're drawing a graph, center is always 0. I'm gonna use 2 of these blocks to represent 1 unit. So 1, 2, -1, -2. So this is my x-axis. We put in some other values. Let's put in some other values. Right, now look at your y values. You have a -1, a 1, and a 3. So that should tell you how you're going to space out your graph, right? So we need to have a -1. So I'll still use the same 2 blocks to represent 1 unit. And we need to get up to 3. So 1, 2, and 1 more up here, 3. Right? Always label the axis, y-axis, x-axis. You write your scale. My scale is 2 centimeters, represent 1 unit on both axes. Right? And we plotting points. So doing this one here. So -2 on 1. -2 is on the x, -1 is on the y. So from 0, I'm shifting to the left. When I have a minus on the x, we shift to the left. So -2, and then the other point here is -1. When I have -1 on the y, we go down. So minus on the x-axis means our movement from the origin is 0, to the left. And a negative value on the y means movement down from the origin. So I'm going 2 to the left and then 1 down. So 2 to the left and 1 down, we'll put my right here. Right? The next point we have is the point 0, 1. So we're not moving anywhere. We're staying right here, but we're going up 1. And then the other point is 2 and 3. So I'm going 2 to the right and then 3 up. 1, 2, 3. Right? And we're going to, now, because we're doing simultaneous equations, these lines that you're drawing from we need to extend them. All right, so just extend them up both sides. Bam. Oh, and we're doing simultaneous equations, so I have to put both of them on the same graph. Let's look at the values they have. -2, 0, 2, so we have that on the x. Y, we have a -5. I don't think we had the -5 here, so let's just extend this line and include that. Right, so -3, -4, -5. I'm borrowing these points, so I'm dropping them a little closer so that we could see what we're doing. Just going to write them on the side here, right? So again, -2 and -5. So we're going 2 to the left and then 5 down. So 2 to the left and 5 down. 1, 2, 3, 4, 5. So you see it's in line with -2 and in line with -5. Then we're doing 0, so we're not moving left nor right. We're staying right on this line here and go down 1. Bam. And then we're doing 2 and 3. Right? Which is the same point they have up here. So let's draw our line. Excuse. I'll fix that. Now what we're looking for is a pointer intersection. And we can clearly see that the pointer intersection is going to be right here. Everybody see now? Now look at this. This point here is the point 2 on my X and 3 on my Y. Everybody see now? That's my X value. That's my Y value. So the answer to the simultaneous equation is X is equal to 2 and Y is equal to 3. Right? It's the point of intersection, meaning the point at which the two lines cross each other. Now, when you're doing this, you need 3 points, but you're not going to stop the line at the point. You need to extend the lines outwards. So you give them an opportunity to cross each other's path. Because where they cross each other's path is where you want to draw an arrow coming down to see what number it's in line with on the X, and across to see what number it's in line with on the Y. And that is where your answer to a simultaneous equation will be if you're using a graphical method. Yeah?